So here are the G3 reflection solutions, and here we're looking at sampling distributions for means, averages, as opposed to proportions. So which of the following is an incorrect statement? The sampling distribution of X bar has a mean equal to the population mean mu, even if the population is not normally distributed. So if it's a proper unbiased sampling distribution, those are the same thing. So this one is true, all right? Then it asks about the standard deviation. Well, that's pretty much the formula for the standard deviation. So we're fine there. And then finally, well, actually it says the sampling distribution of X bar is normal if the population has a normal distribution. That is true. When n is large, the sampling distribution of X bar is approximately normal, even if the population is not normally distributed. And then finally, the larger the value of the sampling size, the closer the standard deviation of the sampling distribution is to the standard deviation of the population. The problem with this one, the reason this one is incorrect, is we're already showing this is population standard deviation. So the larger the sample size becomes, the smaller the standard deviation for the mean. So E is the correct answer on this one. Number 2, it is estimated that school CO2 levels average 1200 ppm with a standard deviation of 300 ppm. In a random sample of schools, what is the probability that the mean CO2 level is more than 1000 ppm, a level at which some researchers feel will cause a drop in academic performance? So first of all, if you're looking at the answers here on the left, you'll notice that they're in an interesting format. These are z-scores or test statistics. You can probably guess it's not this one, partly because I have not taught you the t-distribution yet. And yes, there is a t-distribution. We'll get to that in a little bit. So we're going to use a standardized test statistics. So this is on your math chart. And the reason it doesn't just say z-score is because there are other test statistics besides the normal distribution. But it's your statistic minus your parameter, or your value minus your parameter, divided by the standard error of the statistic. So the only thing we really have to modify for, we know the statistic, we know the parameter, we need the standard error, which would be basically the standard deviation for the population divided by the square root of the sample size. So it would be z equals 1000 minus 1200. All over 300 divided by square root of 30. Choice A. Suppose using accelerometers and helmets, researchers determined that boys playing high school football absorb an average of 355 hits to the head with a standard deviation of 80 hits during a season, including both practices and games. What is the probability on a randomly selected team of 48 players that the average number of head hits per player is between 340 and 360? So first of all, they're asking what is the probability that the mean of the team, so it's a statistic, is between 340 and 360. Well, the mean for the team is just the mean for the population, or for the sample, so that will be 355. And then I have to find the standard deviation for the sample, which will be the population standard deviation over the square root of the sample size. Well, the population standard deviation is 80, and the sample size is 48, and so I get about 11.55. Now, if I were putting this in the calculator, it would be normal CDF, so that would be second distribution to get there. Lower is 340. Upper is 360, the mean is 355, and standard deviation is 11.55. So it would look like that if you put it into the calculator. And it will give you a number, and actually I'm going to go ahead and show you the Staplet output because I like for you to see what the curve looks like. 360 is just above the mean, and 340 is a little bit below the mean, and your area you can see is actually greater than 50%. So it's about 57.04%, which rounds to answer C. Suppose sleep-trained babies allowed to cry themselves to sleep wake up an average of 1.2 times a night with a standard deviation of 0.3 times. while non-trained babies wake up an average of 1.8 times a night with a standard deviation of 0.5 times. In a random sample of 80 babies, half of which are sleep trained, so 40 are sleep trained, 40 are not, what is the probability that the non-trained babies in the sample wake up an average number of times greater than 0.75 more than the average of the sleep trained babies? So this is what we're looking at. What is the probability the difference in the sample means is greater than 0.75? Now, you'll notice I said sample means here, right? And so we're estimating, we're going to use the mean for the differences, which is the difference of the population mean, so we get 0.6. Then we have to calculate the standard deviation. That's the formula on your math chart. And substituting in, we get 0.0922. And then basically now we say, okay, so our lower is 0.75, the upper is infinity, and then the mean difference for the population is 0.6, and the standard deviation of the difference for the population is 0.0922. And that's pretty much what you get when you put it in the calculator, or if you put it in the Statlet, it looks something like this. So it's the area to the right, 0.75, and since the average is 0.6, and you can see the standard deviation is quite small, it's not a very big area. It's about 5.19%, which is choice A. The owner of a coffee shop, an amateur statistician, advertises that the price of coffee on any given day will be randomly picked using a normal distribution with mean $1.35 and standard deviation of 10 cents. If a customer buys a cup of coffee on 10 days, what is the probability he will pay a total exceeding $14? So, couple ways to do this. Probably the easiest way to do it is to look at the average. So if he bought coffee on 10 days and a total of 14, we could say, oh, what is the probability that the average, which is greater than $14 over 10, so $1.40 basically, that's what we're looking for. Now our mean is $1.35 and our standard deviation is 10 cents for the population. The mean for the sample should be, or for the sampling distribution, is $1.35. The standard deviation for the sampling distribution is 10 cents divided by the square root of the sample size, which is square root of 10. So we get 0.0316. So if I want the probability that the average on my sample is greater than $1.40, then I would basically do normal CDF using the lower of $1.40, the upper of infinity, and mu of x is using the mu for the sampling distribution and standard deviation for the sampling distribution. So substituting those all in, I get 0.05679. And just for good measure, here is the graph from the Statlet. You can see we pretty much had the same answer, and you can see that it's pretty small. So the correct answer is B. Number 6, the amount of omega-3 fish oil in capsules labeled 1,000 milligrams is measured for 4 manufacturers' products yielding the following. So this is the graph. Which one has the smallest range? Well, range is max minus min, including outliers. So you might be saying, oh, that's pretty tight, or this one right here. But the problem is, see, there's an outlier there, there's an outlier there, there's 2 outliers here. Manufacturer C, or company C, has the smallest range. So don't ignore outliers, they are data. A company wishes to survey what people think about a new product it plans to market. They decide to randomly sample from their customer database, as this includes phone numbers and addresses. This procedure is an example of which type of sampling. First of all, they didn't explain how they randomly chose. So they sort of said random, but no methodology. All right, so I'm like, well, I have no idea. Not only that, they have issues. It is a convenience sample. But they also sampled only their customers, so there's also undercoverage bias. So If someone says, oh, I randomly chose, unless they can tell you how they did it, we're going to assume, convenient sample. Now, if you get a big free response problem and they're like, oh, the sample is randomly taken, that's fine. But here, this one, they were trying to ask you which method, so that was a hint. It was convenience. Not my favorite problem I put on your assignments. Sorry about that. So to me, it's like, they could have been a little bit clearer that that was a convenience sample. So if you get a free response problem, make sure that you understand that if they say they randomly sampled, and usually it's professionals, you can say it's random. Okay, don't assume it's convenience unless you have a good reason. All right, number 8. Define a new measurement as the difference between the 60th and 40th percentile scores in a population. This measurement will give information concerning, this is spread, so it would be a measure of variability. And there you go, it's answer B. Okay, number 9. Suppose x and y are random variables with the expected value for x is 37 and the expected value for y is 62. What are the expected value and variance of the random variable x plus y? This feels almost like a trick question because they did not tell you they are independent random variables. So we need to know they're independent before we can add them. So the correct answer on this one is E. So very tricky question here. You have to, don't just start doing the math, they must be independent. Okay, number 10, which of the following can affect the value of correlation R? A change in measurement units. No, actually R does not have units, it's false. A change in which variable is called X and which is called Y. Well, hopefully during Barbie Bungee Jump, you saw that when we switched them, correlation did not change. B is false. Adding the same constant to all values of the X variable. Well, adding a constant only shifts the equation. It does not affect correlation. C is false. So that means that all three, none of these are affected. So the correct answer is E. Okay, number 11. Which of the following sets has the smallest standard deviation? Which has the largest? Well, I went ahead and I just plotted all the data. It's much easier to visualize. And you can see all 3 dot plots for sets 1, 2, and 3. Set 1 is kind of evenly spread out. It doesn't have the least amount of spread, but it definitely has some spread. Set 2 looks like it has the largest spread. And then set 3, I would say, is the tightest. Now, one thing you could do is you could actually put all these data in your calculator and do one var stats, and it could give you the standard deviations. I went ahead and put it in Statplet because it also gave me the dot plot. And you can see this confirms the standard deviation is the smallest for set 3, but it's the largest for set 2. So the answer is E. Number 12 through 13, bias and variability. The figure shows approximate sampling distributions of 4 different statistics intended to estimate the same parameter. Which statistics are unbiased estimators? Justify your answer. So remember, here is the parameter. This is the true value. The closer that the average for the group is to the parameter, the less biased it is. So we're definitely going to say that the first one is underestimating in general. The second one looks pretty good. We're going to say unbiased. You're like, but there's a little skew. Well, it's pretty close, all right? And then here we have another one. The average looks somewhat close to that. So we're going to say that one's unbiased as well. And then this one is clearly overestimating. So 2 and 3. Because the means of their sampling distributions appear to be equal to the mean of the population. On to number 13. Which statistic does the best job of estimating the parameter? Well, we definitely want it to be minimize bias and variability, so we're going to limit it to 2 and 3. If you look, 3 has a lot more variability, so I wouldn't be as keen on using that one. I'd much rather use 2. Number 14, a researcher plans a study to examine long-term confidence in the U.S. economy among the adult population. She obtains a simple random sample of 30 adults as they leave a Wall Street office building one weekday afternoon. All but 2 of the adults agree to participate in the survey. Which of the following conclusions is correct? Well, first of all, people walking out of a Wall Street building that work there, well, they either do business there or they're employed there. Either way, they probably make a good living. They are not representative of the population at large, which would make this an undercoverage issue. Problem 15. The mean law school aptitude test, or LSAT score, for applicants to a particular law school is 650, with a standard deviation of 45. Suppose that only applicants with scores above 700 are considered. What percentage of the applicants considered have scores below 740? Assume the scores are normally distributed. So we're looking for the probability that X is less than 740, given they were considered. In other words, if they scored at least a 700. So since this is a given probability, we have the formula on the math chart right in the front. Probability of A given B equals probability of A and B divided by probability of B. So when does both of these occur? If their scores are between 700 and 740. So I'm going to rewrite this first one, given, right? So we have between 700 and 740 and greater than 700. So the percent that have below 740 but are considered is this area right here, 0.115. You could have done normal CDF and made sure you put in that mean and that standard deviation. And then all the people considered, 13.33% of people were considered, and 11% of people were considered and between those two scores. So we put those two values over each other, and we get 0.82896, which is pretty much 82.9%.